Good evening, everyone. A warm welcome to all of you to this evening session of the ATAL Online Faculty Development Program on empowering society, leveraging advanced communication technology for a connected and resilient future. It is a pleasure to have such an enthusiastic group of learners and professionals joining us. It gives me great pleasure to introduce our esteemed speaker for this session, Dr. V. Saravanan Balaji sir, Senior Member of IEEE. He is currently affiliated with Development of Computing, Montfort University, Kazakhstan. He is having 18 years of teaching and research experience. His research interests are machine learning, cloud computing, and optimization techniques. So far, he has published more than 40 research articles in various indexed international journals and conferences. Now, Dr. D. Saravanan Balaji sir will take us through the exciting topic shaping the IoT landscape, the role of 6G technology. Please join me in welcoming Dr. Saravanan Balaji sir to share his expertise with us. Over to you, sir.
Okay, thank you. Let me share my screen. Hope you all can see my screen, yeah? Excuse me.
Yes, sir.
Yeah, you can see my screen, yes?
Yes, sir. Able to see, sir.
Yeah, yeah. Okay, thank you, thank you. Good evening to one and all. First of all, I thank the Vellalar College of Technology management as well as the department people for inviting me to present to taking this session, which is shaping the IoT landscape, role of 6G technology. Actually, it is a great initiative by the government of India to sponsor these kind of faculty development programs across various institutes in the India and make the people to learn new trends without any registration or without any payment, which is actually a great initiative. Thanks to the government of India. And I also thank the people who are all applying for these kind of FTPs to conduct in their institution. And now I welcome you all to my presentation. Uh, Today's my presentation, the agenda is are of four parts, where in the first part you can see that IoT evolution and current state. Because before getting into the 6G technology, we should understand what is the current overview of IoT, as well as what are the various challenges which are all faced by the IoT environment today. So that is what my first part of presentation will be. And my second part will be 6G technology deep dive, where I will discuss about the foundational aspects of the 6G technology, because you should understand how the 6G technology is different from the other technologies like 4G and 5G, and how it makes IoT a successful implementation. So that will be my part two, and part three will be integration challenges and solutions. So if you want to use that IoT using this 6G technology, there are certain challenges, mainly in the integration part, as well as what are the various solutions available. That we will have a look over that. That is by my third part. And part four will be the future applications and implementation. So if you want to implement this IoT using the 6G technology, how we can implement that, or how the corporates are doing that. So that is what the roadmap will be covered under this part four. So that is what my today's agenda of my presentation. So let me get into the part one, IoT evolution. So in the IoT evolution, let's see the thing when the IoT term has been coined. Actually, we may think that IoT is very recent technological evolution, but actually, this Internet of Things term was coined by the year 1999 itself. Actually, it was coined by an engineer called Kevin, and he coined this term actually as Internet for Things. For example, he tried to use the RFID technology to make the different devices on that time to share the data with the internet. So he coined the term called as Internet for the Things. Then it automatically evolved to the new term called as Internet of Things. That is what the year the Internet of Things has been coined. Then from the year 2008 to 2012, this RFID and sensor networks have become a very popular one, and all of you might know that, where we have seen the RFID implementation in various environment or domain. For example, supermarkets, or for example, our FASTag, which is also based on the RFID technology. So RFID takes it on everyday's life of at various levels. So that is what the evolution of IoT from 2008 to 2012. So those devices, RFID devices and sensor networks, they enable the data collection as well as the device integration. So that is what the successful implementation of RFID by those years. Then from 2012 to 2016, we all know that the cloud became a new computing paradigm, where instead of having a server or a desktop to perform various operations, the cloud has come into effect implementation, and the companies are providing high level of computing power as well as other software services to even common people. For example, we are all using Gmail and G Drive, where at least 15 GB is given to all of us free of cost. So we can call it as part of a cloud computing, where storage is provided as a service. So that cloud evolution make this RFID and sensor networks also become a part of that cloud. So that cloud integration happened between the year 2012 to 2016. That is what the third stage of IoT historical evolution. Then from 2016 to 2020, the edge computing became a part of this IoT historical evolution, where the localized data processing become the part of edge computing, a main part of the edge computing, because even cloud is very popular. For data processing, you have to depend on the cloud, where sensitive applications cannot depend on the latency of the cloud servers. So this edge computing become a very popular implementation computing technique by the year 2016 to 20, where the localized processing, which leads to the reduced latency as well as improved efficiency. So from RFID, this edge computing become part of the IoT environment. Then from 2020 to current, as of date, you all know about this AI as well as machine learning integration, where we are having various enhanced IoT systems are in place with predictive capabilities. For example, we are all maybe who are all using this Apple or Mac systems. We are all having this sensors integrated into our Mac iPhones or the Mac systems, which will sense the environment and which will give alerts. So they are predicting the future, the near future. That's what the current IoT scenario. AI and ML is integrated with the current IoT systems, which enables the predictive capabilities as well as automation of the entire industrial scenario and real-time decision making. So this is what the IoT historical evolution stages from 1999 to the current AI and ML integration. So now, if you think of the IoT architecture layer, how this IoT, the current IoT has been implemented, actually similar to our ISO OSI model or TCP/IP model, we got to go from bottom to top. So the layer one is called as perception layer, layer two is called as network layer, and layer three is called as service management layer, and the layer four is called as application layer, where the perception layer is actually the foundation layer consisting of sensors and actuators that interact with the physical world. For example, whatever the sensors we are wearing, for example, wearable computing, you all know that we are having smart watches or sensors which we use it in our every day-to-day life. So those kind of sensors are the part of perception layer. Then the above layer is called as network layer, which is actually the communication layer. For example, there are different protocols which are all in use for IoT networks, which we will see soon, the different protocols which are all in use. For example, like MQTT, COAP, HTTP, etc., as well as the technologies like 5G or Zigbee or the 6G. Those are the communication technologies which are all playing a part in the network layer. Then we are having the service management layer, which actually manages the device management as well as the analytical operations and the security for the smooth communication of the data. Because even you are having different communication protocols in hand, the
Yeah, the
main
camera on
thing which we have to take care is the security of the data, because privacy as well as security is a major part in today's scenario. Even a small amount of
Enna?
leakage of data will lead to lot of issues. For example, I think all of you know now there is a recent AI model came into market from China, which beats ChatGPT or
Screen
Google's Gemini models. Can somebody name it?
கண்டதெல்லாம் கிளிக் பண்ணிட்டு இருந்திருக்க.
Can somebody name the AI model which came into market from China, which overcome this ChatGPT as well as your Gemini from Google?
So Devo something.
Yes.
So Devo something.
Yes. Come again, please.
Devo some tool. Devo some tool, I think. So. Like
No.
ChatGPT.
Actually, that
Like ChatGPT.
Yeah, it's okay, fine, no problem. The latest model released from China is called as DeepSeek. DeepSeek, you also can check it out. DeepSeek is a latest model which came into market, and it is actually performing better. The reasoning model is better than the ChatGPT. So, because of that, the US market, which is based on the AI companies, is completely crashed. Crores of rupees went out, taken out by the investors, because this model is very cheap and it is completely free. You can also try it out. But what happened today is, as this model was released last week, what happened is lot of attacks, malicious attacks or DDoS attacks happen over the system, because the system is not secure enough like ChatGPT or Google Gemini. So this makes the system to downgraded for some time. So as I said, even a new technology is coming up, security is major part. So this security is taken care by this service management layer. And the last layer in the IoT architecture is the application layer, where this architecture application layer is the layer where you all know the applications are running, which act as an interface for the end users, as well as it supports different applications for predictive maintenance, asset tracking, and healthcare, etc. So whatever we are seeing on our smartphone or on the screen of the laptop or PC or on the server, those applications are running on the application layer of the IoT architecture. So these are the 4 layers of IoT architecture. So let's see each layer with different components. So if you think of the perception layer, actually this perception layer is consisting of different components which are called as sensor technologies, actuator systems, data acquisition methods, and physical parameters. So you can ask, what is sensor technology? Sensor technology is not a new one. It is the very old technology where a lightweight, small sized sensors placed in different places of the environment, which actually captures the real world data. For example, it will capture the temperature or the pressure or the motion of a particular human or any other element from the environment. So sensor technology is not a new one, but it is also a part of the perception layer of IoT architecture. Then the actuator systems. Actuator system is the most important one, where it actually convert these digital signals, which are all captured from the actions sensed by the sensors, and it enables the interaction with the environment. So actuator system is the higher level than the sensor technology. Then the third one is called as data acquisition method, where data acquisition method means it ensures the accurate and efficient collection of data from various physical parameters. For example, if you are having different sensors placed, one sensor is for temperature, or one sensor is for motion, or one sensor is for pressure, then those sensors are sending different data at the same time, and you should have a effective data collection method so that you can separate those data very clearly without any errors, and you can submit it to the cloud server or any other server for further processing. So data acquisition method is also an important one, which people who are all working in the machine learning might know that, because removing the noise data is an important part. And the last one is the physical parameters, where you are defining the parameters of the environment so that you can decide what are the different data you have to collect. Based on the data, you are going to decide what are the sensor technologies or actuator systems you need to place in the IoT environment. So these are the different components of a perception layer. Now the next layer is called as network layer, where if you think of the network layer, you can divide the components of network layer into two things. The first one is called as protocols, and the second one is called as technologies. Because even you are having different protocols, without the technologies, the protocols cannot perform very effectively. For example, if you are having HTTP, and this HTTP protocol is able to send and receive data, but you are having a technology called as 2G technology. I think the people who are little older in the 90s or 80s, they might know the 2G communication effectiveness. So even your HTTP protocol is efficient in data handling, but without the technology for data transfer, then it will not be an effective network for data communication or data processing. So that's why this network layer components is divided into two sections. One is protocols and another one is technologies. If you think of the protocols for IoT especially, there are three plus one. We can see that MQTT, the first protocol, the second one is called as COAP, and the third one is HTTP2, and the last one is WebSocket, where MQTT means message queuing telemetry transport. Actually, this is a protocol which is a lightweight protocol for sending and receiving data using from the sensor to the centralized data collection point. So the sensors are using this protocol for sending and receiving lightweight data. And the second one is called as COAP. This protocol is called as constrained application protocol. So this constrained application protocol will apply certain restrictions on the applications to process the data in a specific manner. It cannot be like normal networking what we are using for today's communication. So this is a separate protocol, especially for IoT. And the third protocol is called as HTTP2, which you all know that HTTP version 2, which is for faster data transfer over the applications. So that is what the third protocol. And the WebSocket is very common, where we are having a socket for sending and receiving data between two ends. That is what the common terminology we use for communication in any programming language or in any networking side. So these are the protocols which are part of the network layer in IoT. Then we are having the technology side, where if you think of the current technology which is under use is 5G NR, LoRaWAN, NB IoT, and the ZigBee. 5G NR means it is actually fifth generation networking communication technology, where it is used for high speed data and ultra reliable connections. So this recent IoT is based on this 5G NR, as well as LoRaWAN. You all know about that, the long range low power connectivity wide area network, which is also used for sending the data from the sensors in a wide area network manner. Because you all know, when you think of the home automation or other kind of smaller networks, we call it as a local area network. But when you think of communication from sensors from broader area, for example, if you are sensing a forest, then this forest cannot have a different local area networks for communication. So in that time, then you can go for using the LoRaWAN technology also. And then NB IoT, this is another technology which is for implementing a large scale IoT deployments. So that is what the third one. Then the last one is called as Zigbee, which is mainly for communication within a short range. For example, if you are think of home automation, this home automation is completely based on this Zigbee communication technologies. So these are the different technologies which are part of current IoT, where we are having implementation methods for successfully implementing the IoT in different regions. The next one is the third layer of the IoT architecture, which is called as service management layer. This service management layer is consisting of 4 components, where you can see that device management, data analytics, security services, as well as API management. So if you think of the device management, this device management is the component which ensures all the devices which are all part of the IoT network are completely monitored and updated frequently with the software, as well as those are all maintained effectively. Because when you are having an IoT or when you are having a sensor network, the constraint for this type of networks is the battery power. If you are having these devices running on battery power, then the battery power will not run for a long time. So you have to use the existing amount of power in an effective way. So you have to make the devices sleep as well as active in a cyclic manner, so that you have a long time network lifetime. That is what this device management component is doing under the service management layer. Then the next one is called as data analytics. If you think of the data analytics, this component actually process the vast amount of IoT data. For example, all of you now we are talking about AI and MI, which is actually helping to processing the big data, where actually the big data comes from is because of the sensor networks. Because the sensors which are all used in space research, or in the ocean research, or in the huge sized research domain, then so these sensors are generating terabytes of data per second. So capturing that data and processing in an effective manner need a new computing method, where this big data, which is actually based on parallel processing, came into effect. Okay, so that is what this data analytics component is doing. It actually processes the vast amount of data collected by the IoT sensors to extract the or infer the actionable insights from the data for decision making. So that is what the second one, data analytics. And the third one is called as security services. As I already said, how much data you may have or how efficient your system is, but your system should be more secured. It should not be easily attacked by the hackers. Why? Because no system is 100% protected until the system is not on the part of a network. But IoT itself is a network, so it is always prone to different attacks. So you have to ensure that the security services can secure your IoT network from the well-known common attacks. So these security services are very important for protecting the data as well as devices against the cyber threats. That is what this third component called as security services is doing. And the last component of the service management layer is called as API management. Actually, this API management enables the seamless interaction between the devices as well as the application. You all know what is API. As a programmer, you should be aware of how to create an API for effective communication between different services as well as devices, which is called as application programming interface. So this API management layer ensures that this IoT ecosystem is capable of sending and receiving data between different devices in an effective way, so that the data will not get lost or the data cannot be processed at both ends. So this is the duty of the API management under service management layer. So these are the 4 components of your service management layer. So far we have seen 3 different layers in IoT architecture: the perception layer, network layer, service management layer, and the last one we are going to see is called as application layer. So as you all know about this ISO OSI model or TCP/IP model, application layer is the layer where the applications are running and the users are using that application for sending and receiving data. Similarly, here in IoT network also, this application layer is the layer where IoT applications are running. So if you think of IoT applications, you can divide those applications into 2 sectors. One is industrial applications and the second one is consumer applications. Why it is industrial and consumer is, depend upon the consumer, you have to decide what level of IoT network to be implemented to fulfill the requirements of the consumer, the customer. So if it is a bigger industry, for example, a car manufacturing industry, then the car manufacturing industry requirements are completely different from a consumer who is actually looking for a smart home automation. So that's why, depend on the level of the requirement from the customer, the application layer is divided into 2 components or 2 sectors called as industrial sector as well as consumer sector. In the industrial sector, the applications are mainly developed for predictive maintenance. As I said, if you are having a car manufacturing industry, then you should monitor each and every part of your industry, like small level machines to the higher level machine assembly units, and you should be able to predict when the maintenance should be done for each and every machine in the industry. So that is actually happened by using the IoT network, which continuously monitor the machine's output, like temperature or number of units it's produced, or what is the level of the fuel, etc., etc. So, and it will helpful for the managers of that industry to predict what will be the maintenance time, so that they can make the machine to run continuously. As well as asset tracking, this is mainly used for your supply chain management as well as other tracking management systems. So that is what the second one, asset tracking. And then quality control, which is most important one. Whatever the industry is, they have to fulfill some quality of service or maintain the quality of service. So for that purpose, this quality control is an important part, which can be achieved by using the IoT system. So if you come into the consumer side, for example, people like us, we also need to use the IoT networks. For example, most of us are willing to set up our home as a smart home, where we can monitor the environment, outside environment of the home, as well as the temperature inside the home. Is there any fire inside the home? Like these kind of things. So different requests are needed to be monitored by using different sensors. Example is smart home. For example, you can automate the complete lighting of the home, heating sensor, as well as security of the home. Then the healthcare, which we all know about that. Remotely monitoring the patient's current health status. For example, nowadays you all may need see that news. Many doctors from US or from India, they are operating on the different part of the world using the robotics as well as this IoT. So that is what called as smart healthcare, which helps for the doctors to understand the current status of the patient, as well as they can predict what will be the near future for the patient, and they can prescribe some medicines as well as practices for every day-to-day life. That is what the healthcare, an example for the consumer side IoT. And the last one, urban mobility, which is the very famous one, where you all know about the Tesla as well as other car companies from China also, which are completely using this urban mobility, which is not yet came into complete usage under India because of our own constraints. But in the developed countries like US or UK, this urban mobility is a very popular one where the cars are self-driven. If you just give the destination and the car can drive by itself, and it can sense the surrounding automatically, and it can decide what action it should take, and it will ensure a smooth operation of the transport. Even this urban mobility is huge success in the developed countries, but still there are a lot of issues on this urban mobility, the smart cars also. For example, if you check the internet, you can see lot of self-driving autonomous vehicles having met with different accidents because of the different environments. For example, one case, very famous case in the Tesla, I think the Model 3, I'm not sure about that. You can check it that a few years back, the car, when in the intersection of the road, there is a complete white color truck is going on, it crossing the road, and this car senses the environment, and because of the brightness of the sun, it cannot sense the white color container, and it directly hit with that container. So this is what some drawbacks are happening in the autonomous vehicles, but still it is a huge achievement from the previous generation vehicles. So this is all different applications where the application layer is helpful for customizing the IoT output for different specific industries as well as different specific consumers, which enhances the productivity as well as the user experiences. So these are the 4 layers of the IoT architecture which we have seen so far. Hope people can follow what I'm talking about that. Now, so you can ask, so everything is fine, looking fine based on the IoT of current state, but still the current IoT or IoT network are facing numerous challenges. Let me go through some challenges of the current IoT network is. First of all, scalability issues. As I said, even you are having an effective communication method, still you are not able to cover the greater area. For example, implementing the LoRaWAN for a complete city or a complete country is not yet completely practically feasible. So the scalability issue is still a major issue for the IoT environment. Managing the billions of connected devices is the big challenge. Then the device system. As new technologies and new sensors are coming up with different capabilities, seamlessly integrating these devices into the existing systems. For example, if you think of the people who are little older than the current students, we were all used to use the IP version protocol, IP version 4 protocol, but now the new systems are coming up with IPv6 protocol version, and we have to develop a new technology for converting or make the communication possible between IPv4 to IPv6. The same has been applicable to the IoT network also, because of evolution of the new devices as well as sensors. So integrating those devices into the existing IoT network and managing the life cycle of those devices is really a difficult task for the current IoT ecosystem or current IoT networks. As well as third one, you can see that network congestion, which is very common in any network, especially if you are going to use the wireless network, then congestion is very common, which automatically lead to the higher latency as well as huge number of packet traps or data loss will happen. So that is also an IoT challenge, current IoT challenge. Then the security concerns, which is very common. However, new technologies are coming into market. Every new technology is always having their own drawbacks or loopholes, vulnerabilities. So security is always a concern for any new technology. Then you can see that device vulnerability, which I already told, say it's part of security concerns. Data privacy. For example, data privacy, you can see that maybe in 1 or 2 months back, I'm not sure about the timeline. There is in US, the people who are all using a smart robot for cleaning the house, which got hacked by the people from some other country, and they are able to steal their username and passwords. You can check on the internet for this case study. So privacy of the users is always a problem because this IoT is dealing with more sensitive data. For example, if you think of the healthcare data, like a person's age, what is his current blood pressure, and what is his current heart rate, or what is his current glucose level in the glucose level in the blood. So these are all sensitive data for a particular user, which cannot be disclosed common to any platform. But stealing this data from the sensor devices is very common, which is happening frequently. So privacy of the user data is a rising concern in the IoT network implementation. Then integration, as I said, different techniques, different sensors are coming, or different applications are developed. Integrating with the existing one is always a complex one. Then protocol fragmentation. For example, here why protocol fragmentation means different sensors developed by different companies. They try to develop their own protocols. So the compatibility between the protocols is always an issue. For example, you all know this Apple phones or iPhones are nowadays coming with the USB-C support. But before that, it was not at all there. Because of that, the people are not able to use the existing chargers or connecting devices for connecting with the iPhones. So the European Union strictly told to the Apple systems that you should adopt the USB-C type for your new manufacturing devices. So this is what an example for this compatibility issues. So that protocol fragmentation is always a problem. Then the legacy system. Legacy system is already the existing systems which are in use for a longer time. How to make that system data to adapt this new data so that it can be more effective. So these are the various IoT challenges for the current network. I hope you are following me so that you understand what are the various challenges of IoT, as well as the architecture and history of IoT evolution. So now what actually the researchers are doing is to solve these issues, for example, scalability, network congestion, etc. They are trying to make the IoT to adapt the 6G technology so that this IoT network can be more effective in nature. Okay, so that is what we are going to see. So before getting into the 6G IoT plus 6G technology, let's see the 6G technology basics. So here in this slide, you can see the 6G technology's core specifications. The core specification is first the frequency range, 100 gigahertz to 10 terahertz, which is a huge jump from the current 4G or 5G data transferring frequency ranges. So it can operate at a higher level of data capacity. For example, you can see there the peak data rate that can be transferred using this frequency range is 1 terabits per second. For example, even we are using 5G nowadays in India, we are not able to reach 100 Mbps in the mobile phones right now. Still, we are having that difficulty. But when the 6G technology came into everyday use, then the peak data rate which we can achieve is 1 terabits per second, which is a huge volume of data, as well as the latency. Latency, you all know the time taken between transfer of data between one end to end and receiving the reply. So when you are using this 6G technology, the latency will be less than 100 microseconds, which is actually a huge jump from the current latency, which is in affecting the current networking operations. So that is also a good value. Then the connecting density per kilometer. You can see there per square kilometers, you can connect 107 devices per square kilometer, which are all able to transfer data at the rate of 1 terabits per second. And the latency also will be less than 100 microseconds, which is, sorry, it's not actually 107. There is a mistake. It is 10 million devices. It should be 10 to the power 7. Because of typing mistake, it is like 107. Actually 10 million devices can be connected within a square kilometers, which enables the big size of IoT networks. So sorry about that typing mistake. So these are the core specification of the 6G technology. So now let's see about the 6G network architecture, because we already know about the IoT network architecture. So now if you want to migrate it into 6G network, we should understand what is the 6G network architecture. So in the 6G architecture, as you can see here, there are 4 layers are there: core network layer, ground network layer, edge computing, air network layer, as well as space network layer. So this core network layer is, you all know, which is already existing network for communicating between different parts of the world, which we are enabling it as using AI native things. For example, you all know we are now, companies are trying to implement the SDN at various levels. So those what called as core network. And if you come to the ground network layer, where, as I already said, to make the environment or the system which is monitoring the current environment to take quick decisions, you have to deal with the data at the place where it is generated. So this edge computing based ground network layer is an important part of the 6G network architecture. So this core network as well as ground network, which includes the edge computing, enables the data processing and analysis from the place where the data is generating. Then the air network layer. Here you can see that what is air network layer. Actually, this air network layer is a network layer where your UAVs or drones acting like relay stations. For example, if you all know, the last 2 weeks before, there's a huge forest fire happened in Los Angeles in US. And if it is a huge forest fire, in that huge forest fire, you cannot implement the current IoT by traveling inside the fire. But if you are having this 6G network, you can use your UAVs or drones to acting like a relay stations, which will fly over that forest and can sense the network. So that is an advantage of this air network layer, where UAVs and drones are acting as the relay stations. And the last one is space network layer, where the communication points are the satellites. So these satellites can provide global coverage for the remote areas. For example, you all know about the Starlink, as well as other companies are also coming in to provide the networking internet services using the space satellites. So these are the components or parts of our layers of 6G network architecture, which is completely different from the current IoT network architecture. The next one we are going to see about is 6G technologies, where, as previous slides, this 6G technologies can be divided into two things, which one is communication based and another one is computing based. Where if you think of communication based, the technologies behind the 6G is terahertz of data transfer, ultra high speed data transfer for bandwidth intensive applications. For example, if you are transferring a live concert or live cricket match or live football match, then that live communication need a huge bandwidth, where the current network is based on entirely using wire network or the current satellite communication, which you cannot serve multiple people. But when you are going to this 6G technology, this terahertz communication enable a huge bandwidth for transfer of data. And visible light communication, that is the second one, where it will use light sources for secure high speed communication. This is also under complete research, using the light for data transfer. Then quantum computing, which you all know about that, which is completely under the research by the corporates, where it will provide computational power at huge level, and which will provide complex problem solving within few minutes. For example, last or 2 weeks before, I'm not sure about the timeline, you can check that the Google quantum computing solved one mathematical problem which actually requires trillions of years to solve if it is done by a human or normal computer. Trillions of years to solve that problem, but the current Google quantum computer solved it within 5 minutes. It's not in seconds anyhow, but it solved it in 5 minutes. So you can check that case study also. So that is what the quantum computing capability is. So as well as if you come to the computing side also, distributed AI, distributed system is a part of always a communication scenario where you can process the data locally like edge computing, and you can reduce the dependency on the centralized systems. This quantum computer and molecular computing are still under research, where high level computing power is coming to use for every human maybe within few years. So these are the key 6G technologies. So as of now, we have seen the IoT network architecture as well as 6G network architecture, and what are the challenges of IoT, and what are the technologies which will make this 6G as a huge success. Now we are going to see how this 6G technology can make this IoT and most successful network, which will be help to industries as well as common man. So we are going to see about that. So that is what we are calling it as first one, 6G IoT integration framework, where if you think of this current IoT and the 6G to be integrated, you have to think about the integration in different layers. For example, you can see here the physical integration, network integration, data integration, and service integration. If you think of the physical integration, as I told already, the sensors which are currently we are having, which should be able to support the 6G communication by having a powerful antenna. So designing an antenna is a challenge for this, and you have to enhance the battery also. For example, sending data in 2G speed will not take up much power from your mobile phone, but if you are sending data in 1 terabits per second, means the data amount of energy the device will take is very high. So you have to have a solution for that. So that is what the physical integration. Then the network integration means the already existing network cannot be disturbed at any cost, because millions of dollars or billions of dollars are already spent for establishing the current network, and you are going to make the protocol adaptation from the current network and the future 6G network, and you got to make the AI to decide the resource allocation as well as network slicing for effective data communications. So that is what called as network integration. And if you come to data integration, you have to focus on real-time data analytics as well as distributed storage, because for the current network itself, centralized storage is not possible. So distributed storage as well as real-time analytics is very much needed for massive data management. Then the service integration, where you have to have API design for enabling the microservices communication, as well as you have to make the API a standardized one, so that different developers or different companies can develop their own sensors or technologies and send and receive data through that standardized API. So this is a framework where you have to concentrate for 6G as well as IoT integration. So now let's see the challenges for each integration. For example, the first one which we have seen it as physical integration challenges. So as I already said, the sensor which we are having, they should be able to send and receive data in a huge volume. So you have to have a terahertz antenna design, which is a very difficult challenge right now for the researchers and the corporates. So that is the first integration challenge. Then the material limitation. For example, sensors are very lightweight as well as easily portable. If you are making a very effective sensor, but it is of 100 kilos weight, means then it is not of use and it will not be used by every person. So you have to have a lightweight sensor with high capabilities. So manufacturing that sensors is having a limitation called as material limitation. What material you are going to use for developing that sensors. Then size constraints, which I already told you now. You have to make it as a minimized one. Then power efficiency, which we already seen that. Small level of communication or the lower level communication methods need very less battery power. But when you are going for higher efficient data communication, need huge power. So that is also effect and challenge. Device miniaturization, where this you, as I said, the device should be a small sized one, which is also a problem. Thermal management for battery power as well as battery technology. So these are the physical integration challenges for making the current IoT to use the 6G technology. The next one is called as network integration challenge, where you can see that if you think of the network integration, you can see it in two ways. One is called as protocol adaptation and another one is called as resource management. Protocol adaptation means what is the sender and what is the receiver. So based on their capabilities, you have to dynamically select the protocol for communication. So that is the first challenge. Then cross-layer optimization. As I said, depend on the different layers, we will have different devices. So the cross-layer communication is also a big issue for that. So that is also an important one. Then semantic routing, that is also for an issue in the network integration challenge. Then the resource management, if you come to this resource management side, AI driven allocation, network slicing, and dynamic spectrum access, that is also an important issue which you have to take care. Just a moment. So these are the network integration challenges which the people have to take care for integrating IoT with the 6G. Then the third part is called as data integration challenges, where the data integration challenges means you have to deal about the real-time analytics, data fusion engine, multi-source data collection, and distributed storage. So why it is important? Because this data integration architecture is always ensures that problem-free data flow and processing across different IoT systems. So that is what the idea began the data integration architecture. So if you are thinking about the real-time analytics, where the data is collected, it should be able to provide the insightful information from the data collected and performing some actions based on the inference. So that is what real-time analytics. Then data fusion means you are collecting data from different sensors. For example, if you think of a environment called as atomic power station, then atomic power station cannot depend on only one sensor. So different sensors are there. So based on the different sensors, you got to collect the different data and you got to fuse the data to provide a unified view so that you can make a more effective decisions. So that is what a data fusion engine. Then multi-source data collection, which we have seen that diverse data sensors are able to collect data. Then distributed storage, spread the data across multiple locations so that you can improve the scalability, reliability, as well as accessibility. So if you have achieved these four parts, then your data integration architecture will be a huge one to support the massive and complex data that needed by the IoT systems in support with the 6G. Then the next one is called as service integration framework. So if you think of this service integration, where we are seeing the application layer connection with this service integration, you got to think about the microservices architecture, where you got to make the applications into smaller pieces so that they can develop and deploy individually. If you are making the applications as a huge level, then it will not be more effective to provide solutions for the users. So you should have a way for implementing this microservices architecture. Then, as I said, API standardization, which is most important for data communication as well as data processing. Then service mesh implementation. Service mesh implementation between means when you are having different services and suddenly a user is requiring a new service which can be created by combining two or more services, then that operation is called as service mesh. So that should be also be ensured so that you can provide the communication between the different services for providing a mesh of services. Then last but not least, the always one is called as quality of service management. Whatever the service you developed, the service should provide a minimum required quality expected by the users. So it should ensure the service QoS parameters like speed, reliability, uptime, etc., etc. So that is what this service integration framework can provide for a complex IoT system. So far we have seen what are the integration issues which we have to deal part by part when you are trying to connect IoT with the 6G. And as this is a recall again, if you are looking at the 6G technical requirements, you can see the big data rate your application should be able to, or the sensor should be able to send in 1 terabits per second. Then the user experience, for example, the user should be provided with at least 1 Gbps per second so that you can support multiple users at the same time. Then the latency should be less than 100 microseconds. Then the reliability should be 99.99% because there is no system in this world which is 100% accurate. So your reliability should be 99.99% at least. So now if you come to the last part is, which is a major problem for implementing IoT using 6G, is energy efficiency. If you think of the existing energy efficiency and what are the solutions you need to think of integrating IoT and 6G is hardware level solutions as well as software level solutions. If you are thinking about hardware level solution, energy harvesting is an important one, where the converting the ambient energy which you have to power the devices. So that is what called as energy harvesting. Then the low power electronics, where you have to design the hardware, the sensors, which will try to use as much as minimum power from the devices. That is what called as low power electronics. Then you should have smart antenna systems, which we already have seen that. This 6G technology supports huge volume of data to be transferred. So your sensors should have a high effective smart antennas so that it can support dynamic power management as well as workload balance so that the energy cannot be depleted very quickly. So these are the issues which you got to take care at the hardware level of the 6G fused IoT networks. So now if you come to the software level, the first thing you got to think about the sleep scheduling, which we already seen that. How you are making sure the sensor is not running always so that the sensor becomes sleep and active in a cyclic manner so that it can have a longer lifetime. So that is what called as sleep scheduling. Then workload optimization. Here workload optimization means instead of relying on only one sensor or only one relay station for sending and receiving communication between the stations or between the sensors, you have to optimize the workload so that different relay stations or different sensors are managing the workload in an effective way so that the energy can be used in an effective manner. That is what workload optimization. Then the dynamic power management, which is also combined with your smart antenna systems and other kind of hardware and software solutions, where you got to manage the power which is currently in the battery so that your network can have a longer lifetime. So these are the various energy efficiency solutions you got to take care of while integrating the existing IoT to the 6G technology. So now so far we have seen what are the different current IoT architecture, what is the current IoT challenges, then what is 6G specification and what is the 6G architecture, and if you want to fuse the 6G architecture with the current IoT, Then so far that is what we have seen. Now we can see if you want to implement this uh, IoT with the 6G, how we can do that. Actually, it is taken care by the corporates right now, as well as a few bigger academic institutes or universities in different parts of the world, where if you plan for that, you can do it in two phases, where the phase one and the phase two, which is general for any real-time implementation for any product, where phase one you have to plan for the infrastructure of the 6G based IoT in a massive scale. So that is what called as infrastructure planning. Then the second one, which is the most important one, which is called as protocol development, because these current protocols cannot support that much huge data transfer. So supporting that huge data transfer capability, you need to develop protocols for that also. And once your infrastructure planning as well as protocol development is finalized, then you can go for creating the test bed, because not only simulation or emulation is not enough for having a guaranteed output or guaranteed performance by the new technology. So what the corporates are always doing is they will go for developing the test bed in a real-time mode, so that they can get the guaranteed or most faithful or trustful results. So that is what the third stage of your phase one. Once you complete your phase one, you can go to the phase two, where you can go for the pilot deployment, which you all know that before going for the real-time usage, they are going for pilot deployment to understand how the things are happening in real time. Then based on the study from the pilot deployment, we can go for refining the standard with the required QoS features. So once everything is fixed, then finally they will take care of the security framework also. Because as I said, even you have an effective system, security is also important. So that is the last stage where more time is spent for managing the data privacy as well as security. So this is the implementation roadmap for 6G and current IoT collaboration. So now, so far we have seen the information based on the hardware as well as software issues, and we have talked about security in a very few points. But actually, after all this integration, successful integration, you have to take care of the security consideration also, because security is most important one. And as you are having the 6G communication as well as quantum computing, AI based decision making, the current security features are not enough for providing the expected security. So what you can go is, you have to think about different security methods, so that you can make this 6G IoT network a effective, trustful security network, secured network. So for example, you can see that the first one you can talk about is quantum cryptography, which depends on the quantum computing, where the quantum mechanics are employed to create the unbreakable encryption, so that the data communication cannot be break very easily. Then you can go for blockchain integration. I think all of you know about the blockchain, where it acts like a ledger for your transactions currently, where the data tampering is not possible or data manipulation is not possible. So integrating that blockchain to the IoT 6G network is also very much needed, so that you can ensure that tamper proof data storage as well as secure device authentication is possible. Then zero trust architecture, where zero trust architecture means you can assume that no device or user is trustworthy by default, so that you have to ensure strict access control methods for users as well as devices to access the network. So that is what called as zero trust architecture. Then we are having called as physical layer security, where which is very common, where needed, because the attack like jamming or eavesdropping is very common in the physical layer. So you got to ensure the physical layer security for your 6G IoT network also. So ensuring the strong security framework is very important for safeguarding your user data and ensuring the reliability of the IoT system. Because if you can't guarantee the reliability, then no person or no industry is going to adopt your IoT system, even it is more capable of sending data and processing data. So strong security framework is very important for your 6G based IoT networks. So when you are thinking of all these things like security, effective power, energy efficiency, etc., you can go for using an advanced use cases for testing up your or implementing this 6G IoT network in different places. For example, if you think of the industrial applications, you can think about the digital twins plus, where you all know this digital twins is very much in research nowadays. Then swarm robotics, smart manufacturing. So this digital twins is capable of making the real-time digital replica of the physical systems, so that you can make this monitoring and simulation is very much easier because of this digital twins plus. Then swarm robotics means you can make the coordination among the multiple robots to perform the complex task collaboratively. For example, right now we are all know that the car manufacturing is completely automated, but still the parts of the car manufacturing is completely independent from each other. So by having this smart robotics, you can make these robotic systems in the car manufacturing industry to collaborate with each other, and they can make the decisions to make the production an effective one. So that is what called as swarm robotics, coordination among the robots. Then smart manufacturing, where smart manufacturing is completely IoT driven with real-time data as well as real-time insights for the production optimization. That is what called as smart manufacturing. Then if you come to the consumer side, because we all know IoT can be implemented in industry side as well as consumer side. So if you come to the consumer side, the applications which we can have using this 6G are holographic communications. That means the real-time 3D communication, which is not came into everyday use still, but the realistic 3D communication is possible based on this 6G and IoT network combination, which is called as holographic communication. Then we can have this brain computer interface, where you can directly interact with the human brains and the devices, which can enhance the accessibility and control. For example, few months before itself, Elon Musk publicly declared that he is going to are using this brain consumer interface as an experiment in his labs. So that is also in near future, which is going to happen. So that is also possible using this 6G IoT technology. Then ambient intelligence. So here ambient intelligence means the environment which can respond according to the human presence. For example, we have already the smart ACs which can understand whether the human is present in the room or not. Based on the human presence, it can increase its output or stop the output, like that. So that is what called as ambient intelligence. So this ambient intelligence is achievable for the entire environment based on the different sensors, based on the different sensing capabilities possible through this 6G IoT communication. So these are the different use cases which are possible by combining this 6G and IoT. So far we have seen the challenges, architecture, the areas which you have to concentrate, and the different use cases. Now, what are the various research opportunities that are available in this 6G IoT integration is? First thing, as I said, developing the sensors using very lightweight materials. So this material science for terahertz communication is a big research opportunity for material science researchers. So that is what one thing. Then the second one is called as AML optimization, where we computing engineers are always part of it. So collecting data, processing the data, making the optimized solution, that is always needed. Then quantum integration, which is as of now currently in the corporate side, integrating this quantum into the 6G. Then bio-inspired network, which is we are also already having a lot of information about this. So these are the research opportunities which we have for our, especially our academia side. We can concentrate on that so that we can propose some solutions on that. So these are the research opportunities. So once the research is done very good and the IoT and 6G are connected successfully and came into everyday use, then what will be the impact? What will be the impact of this 6G IoT combination in society is, you can take it as positive impact as well as challenges. For example, positive impact is the healthcare will be revolutionized completely, because still the healthcare monitoring is not 100% accurate. But by using this 6G IoT networks, the healthcare will become more effective and the data which is generated will be more reliable and the decisions can be more accurate. So that is what healthcare revolution. Then you can think about the environmental monitoring. For example, as you said, this Los Angeles fire, forest fire happened in a remote area which cannot be monitored because of the existing limitation of the existing IoT network. But if this 6G network is came into use, even the remote areas can be easily monitored, and the issues like this forest fire or any other danger, life-threatening situations can be easily avoided. So environmental monitoring is a positive impact. Then educational access, as you said, already we have this seen the Starlink, which capable of providing the internet connectivity to the even remote villages in Africa where people don't have even a telephone, but now they are able to study because of this satellite communication, which will be more effective using this 6G IoT networks. So these are the positive impact. The second thing is challenges, where the first point we all know, digital divide. People are easily get fooled by false information, so they are digitally divided. For example, in India also we are all also having this issue. Yeah, news which is literally not true 100% or not even 1% true can reach billions of users within few seconds, and it have a big impact on the everyday activity. So this digital divide is a challenge. Then privacy concerns always there in any computing. Then energy consumption, which is very much big problem for future green earth initiatives. So these are the challenges on when you are succeeding a 6G and IoT integration. So far we have seen multiple informations in multiple directions in a 6G and IoT. So far what we have seen, the takeaways from this session is, you can understand that this 6G will completely transform the IoT capabilities from current scenario. But this integration requires multi-layer approach, which we have seen clearly. And even that integration is possible, security and privacy are the most important one. And this continued research is essential to implement the most effective technologies in this 6G IoT network. So these are the key takeaways from this session. So let me come to the conclusion of this session, where you can see that this 6G will completely revolutionize IoT because it can address the current challenges like scalability, latency, and integration. So IoT will become a huge success. Then the multi-layered integration frameworks are essential for seamless 6G IoT adoption, which we have seen. Then energy efficiency and sustainability, which is the most important one, should be prioritized in the 6G development. And after this energy efficiency and other things, security frameworks are most important because of the huge computing possibilities. Current security standards or frameworks are not enough. So you got to develop new security frameworks like quantum cryptography, zero trust, which are all most critical and should be followed in every 6G IoT network. Then you got to do continuous research in the AI side, material science, as well as bio-inspired networking for successful evolution from the 6G network to the next level. So for these requirements, there should be a strong collaboration between our academic people, industry, and governments so that you can unlock the 6G potential at full scale. So this is the key conclusion points from my today's presentation. I hope people have gathered some information from my today's session, and I thank the college management as well as department people for giving me this opportunity to share some information about this 6G and IoT integration. So thank you all. If you have any queries, please you can raise.
Participant, any query you can ask. For 12 weeks, the NPTEL program, we studied IIoT 4.0. Within the short amount, all
Okay,
material
ma'am.
has been revised in this session. Thank you for your contribution.
Yes, ma'am. Okay, ma'am. Thank you. Thank you. So hope I can wind up the session. Yes.
One minute, sir. I shall answer the participant any queries, sir. Participant, any
Okay,
queries,
ma'am.
sir? You may ask. Yes, sir. The observing audiences are all are got the point, observed the point. Participant, shall we wind up the session? Actually, our topic is connected and resilient.
Ma'am, yes, ma'am. Session was very good, and if there are no questions, we can ask the resource person to wind up.
Okay, okay.
Thank you, sir. Balaji
Okay,
sir.
ma'am.
Thank you so much for your presentation.
Okay, ma'am. Okay, ma'am. Thank you. Thank you.
Thank you, sir, from the
Manaka
receiving
ma'am, you can
management and
wind
IT
up. You
department.
can begin with that.
Yes, sir. We appreciate your contribution, sir. Thank you, sir.
Okay, ma'am. Thank you, ma'am.
Okay,
Okay.
thank you.
See you all. Thank you.
Okay, sir. We see in another session, sir. On for
Yes, ma'am. See you all.
dedication.
Bye.
Okay, thank you, sir. Participant attendance link has been posted. Kindly post the attendances and join at 8 o'clock. Another session will be started at 8 o'clock. So sharply will be started at 8 o'clock. Thank you.
Attendance rate has been posted. Kindly fill it within 20 minutes.
Thank you, Srija. Srija, we can wind up and we can start at 8 o'clock.
Okay, ma'am.
Okay, okay, thank you.